In today's video, we're going to take a look at ionic compounds, with a focus on how they're structured, what their properties are, and how we can determine their formula. If you remember ionic bonding, it generally involves a metal atom, like sodium, transferring one or more electrons to a non-metal atom, like chlorine, to form two oppositely charged ions. And these two ions will then be attracted to each other by electrostatic forces, forming an ionic bond. And we call the entire thing an ionic compound. In real life though, ionic compounds generally involve tons of ions, not just a couple like we showed at first. And the positive and negative ions alternate, so that each ion is attracted to all of those around it. And as this happens in all directions, it would actually form three-dimensional structures that we call regular lattice structures. So in our drawing here, the green ions represent the positive sodium ions, and the red ones are the negative chloride ions. We can also represent these ionic compounds with ball and stick diagrams, where we show the different ions and put lines between them to represent the ionic bonds. Next up, we need to take a look at the properties of ionic compounds. Specifically, that they have very high melting and boiling points, and that they can conduct electricity, but only when they've been melted or dissolved in water. If you think about any substance, the melting and boiling points are determined by the strength of the bonds holding that substance together. In ionic compounds, there are loads of ionic bonds, all of which are really strong. So to break them all would require loads of energy, which is only going to be available at very high temperatures. When it comes to conducting electricity though, the important thing is whether there are any charged particles that can move. And these could either be ions or electrons. When ionic compounds are in their solid form, everything is fixed, so they can't conduct any electricity. However, when they're melted or dissolved in water, the ions are free to move about, and this movement of charged particles allows them to conduct electricity. The last thing we need to look at is how to determine the formula of an ionic compound. When we looked at sodium chloride earlier, we saw that the sodium had a 1+ charge, and the chloride had a 1- charge. So to balance each other out and become neutral when they combined, we just needed one of each. And so the formula would be NaCl. If we had magnesium chloride though, then it would be a bit different, because magnesium is in group 2. So when it becomes an ion, it loses 2 electrons to become a 2+ ion. So this time, to balance out that 2+, we'd need 2 of the chloride ions, which are each 1-, meaning our formula would be MgCl2. We can also do this with more complicated compounds, like calcium hydroxide or aluminium sulfate. These ones are harder because the hydroxide ions and sulfate ions aren't single elements, so we can't look them up on the periodic table. Instead, you have to memorize their formulas and charges. Hydroxide ions are OH-, and a sulfate ion is SO4 2-. With this in mind, let's take another look at calcium hydroxide. Calcium is in group 2, so we'll have a 2+ charge, and we just said that hydroxide has a 1- charge. So for each calcium, we're going to need 2 hydroxide ions, giving us the formula CaOH2. And notice that we put a bracket around the entire hydroxide ion. This is so that the little 2 in the bottom right tells us that we want 2 entire hydroxide ions, not just 2 hydrogens. For aluminium sulfate though, we have a 3+ aluminium ion, because aluminium is in group 3, and a 2- sulfate ion, which is a bit awkward, because we can't just increase the number of one of them to make the 2 charges balance. So here, we need to find the lowest multiple that 2 and 3 have in common, which would be 6. So to get a positive 6 charge, we'd need 2 of these aluminium 3 plus ions. And to get a negative 6 charge, we need 3 of these 2 minus sulfate ions. So now that we have 2 3 plus ions and 3 2 minus ions, the charges balance out, and the overall formula would be Al2SO4 3. Now, just like hydroxide and sulfate ions, there are a few other ions worth knowing, such as the nitrate ion, which is NO3-, the carbonate ion, which is CO3 2-, and the ammonium ion, which is NH4+. It's probably worth noting these down or taking a screenshot, as it would definitely be easier if you just remember these ones.